From the arid plains of the past to the thriving city we know today, water has always been the lifeblood of Broomfield. It was water that first allowed for the establishment of Broomfield as a small agrarian community in the late 19th century. Today, all of Broomfield's drinking water comes from surface water sources such as rivers, lakes, and reservoirs that are sustained from winter snowpack. Water is a fundamental element of day-to-day life for any community. Not only is it vital to our survival, but it supports our local economy, promotes healthy ecosystems, protects us from wildfires, and allows us to keep our beautiful parks green.
Well, we can't live without it, right?
People do take the water for granted. Most people will go out, turn their faucet on, and they don't even think twice. Most people don't even know what it is exactly what we do.
Each drop of water that we drink makes its way through a combination of both natural and man-made waterways and storage systems. This highlights the importance of long-term planning and innovative engineering solutions. Many may be surprised to learn that the water we drink does not actually originate in Broomfield or from any of the rivers or natural water bodies scattered throughout the Front Range. In fact, most of Broomfield's water comes from many miles away on the west side of a natural hydrologic boundary known as the Continental Divide. It is only through our man-made waterways that Broomfield is able to sustain the thriving and vibrant community that we are fortunate to call home. Today, Broomfield's drinking water comes from two sources: treated water purchased from Denver Water and raw water supplied by the Northern Colorado Water Conservancy District through the Colorado Big Thompson and Windy Gap projects. Northern Water's projects originate on the Colorado and Fraser Rivers on the western slope of Colorado. The CBT project is the largest trans-mountain water diversion project in Colorado. The CBT system collects snowmelt from the upper Colorado River Basin and stores it in Lake Granby. From here, water is pumped into Grand Lake and delivered to East Slope water users through a 13-mile-long tunnel beneath Rocky Mountain National Park. The Adams Tunnel is roughly 10 feet in diameter and runs as much as 3,800 feet beneath the surface of the Continental Divide. At the time it was built, the Adams Tunnel was the longest tunnel in the United States to provide water for irrigation. Over 7 years, 2 crews bored the tunnel simultaneously from each side. When they met, the alignment between the two was off by less than the width of a penny. Today, the CBT project provides supplemental water to 33 municipalities and 120 ditch, reservoir, and irrigation companies that supply approximately 615,000 acres of northeastern Colorado farmland. Denver Water's collection system covers about 2.5 million acres and extends into more than 8 counties. Roughly 80% of Denver Water's supply originates east of the Continental Divide in the South Platte, Upper Blue, and Bear Creek watersheds. The remaining 20% originates west of the Continental Divide, much of which is conveyed to the East Slope via the Moffett Tunnel. The Moffett Tunnel was originally constructed in 1928 as a railroad tunnel and a means for a safer, more efficient trade route between Denver and Salt Lake City. 800 men worked around the clock for 3.5 years to complete the tunnel, which would become the largest railroad tunnel in the Western Hemisphere. 26 died during its construction. Denver Water acquired the tunnel in the 1930s and turned it into the utility's first trans-mountain diversion structure, using the original shaft workers used to access the main tunnel, which also served as an escape route during construction. Broomfield is also the largest shareholder in the Chimney Hollow Reservoir project. Construction of Chimney Hollow is currently underway and expected to be complete by 2025. Chimney Hollow Reservoir will store up to 90,000 acre-feet of water behind a 350-foot tall dam, which is soon to become the 3rd tallest dam in the state of Colorado. Crews are required to dump one 100-ton load of rock every 2 minutes, 24/7, over roughly 3 years to stay on schedule for project completion. Broomfield's water is transmitted to the city from the north and the south via 2 large pipelines and a series of pump stations which work 24/7 to increase capacity and move the water uphill. The city currently relies on the combined capacity of these 2 pipelines to meet peak summer demands and provide a reliable water supply to Broomfield businesses and residents year-round. As our community continues to grow, it's important that Broomfield develops local water storage so that the city can meet our peak demands even after they've exceeded the capacity of our 2 pipelines. Sienna Reservoir is an existing reservoir that the city is currently working to connect to the water supply system via the construction of a new pump station and 20 to 30-inch pipeline. Broomfield Reservoir will serve as a new 2,500 acre-foot peaking storage facility located just west of Sienna.
We're at the Broomfield Water Treatment Facility. We make sure that we meet all the state and federal regulations for drinking water. Essentially what we do is we clean the water to make it so people can drink it and they know it's safe. On any given day, we're protecting 100,000 lives at any given moment.
Broomfield's water treatment facility is a conventional surface water treatment system with the capability of treating 26 million gallons per day during peak demands. Broomfield's water treatment facility treats around 2.5 billion gallons of water, providing the citizens of Broomfield with 4 billion gallons of water on average annually. The plant is operated 365 days a year by a very committed crew of state-certified operators.
This is the last stop after the water has traveled the 43 miles from Carter Reservoir before we begin the process of treating it to make it drinking water. Our main storage area for the water before it comes into the plant is Matthew D. Glasser Reservoir. We work really hard to make sure that it doesn't get contaminated in any way. We have the bird deterrent that we just installed to try and prevent geese and everything else from being on there and pooping in the drinking water. That drop of water, when it comes into our plant, it's kind of like the Snoopy character pig pen. It's covered in dirt, has a bunch of things in it that we want to get out of it. As it enters into our plant, it goes through a rapid mix, which is where we introduce our coagulant chemicals, which is the primary way that we get the dirt off of pig pen. Here on my left hand, I have an example of dirty water that would be getting treated. The water isn't really this dirty, this is just an example. It takes all the dirt and everything else like that, and it separates it and causes all the dirt to drop out to the bottom before it comes into our filters for cleaning. Here we are at the sedimentation basins. This is the first step in the process of cleaning the water. It goes through a rapid mix stage, a flocculation stage, and a sedimentation stage. So we're here in the filter gallery. The Broomfield Water Treatment Plant has 13 filters in total, which can process 26 million gallons a day. Each filter is comprised of anthracite coal, sand, garnet, and gravel, and this is the next step before it goes into disinfection. Sodium hypochlorite is our main disinfectant that we use. Then we add another chemical called ammonium sulfate. The other chemicals that are added at the end is fluoride for oral health purposes, and soda ash is to protect the pipes. So it exits the facility. We have 6 high service pumps is what we call them. They range from 250 horsepower up to 375 horsepower. It's getting pumped out into the distribution system, and it fills the carbon road tanks, and from carbon road tanks we send it out to the west side of town where it fills the airport and Interlaken tanks to make sure that we have enough capacity for fire safety and for everybody's usage and needs. This is the lab that the water treatment plant operators use to run hourly tests. What we do is a total chlorine test for the water that's going out into the system. We run these tests every hour whenever the plant is operating. And as it reacts, it changes colors so we can actually get an accurate reading on how much chlorine is going into the system at any given time. I love my job. I get to do a little bit of everything. I've been working here for 21 years. If I didn't feel passionately about protecting the people and being a servant to the people and a steward of making sure that their drinking water is safe and that everybody's protected, I wouldn't be doing this.
After treatment, water is delivered to our customers through our distribution system, which includes over 370 miles of pipeline, 5 booster pump stations, and 4 water storage tanks. Public Works staff work year-round to operate and maintain the system and plan for future system expansions. Many of us go throughout our day without realizing that there's an extensive system of pipes beneath our feet that delivers our water to our taps each and every day.
We're here at the Broomfield Water Recovery Facility. We treat wastewater to effluent quality that meets EPA standards. This facility is extremely important to the city and county of Broomfield. Without this facility, we would be trying to discharge our wastewater to Denver metro area wastewater facility. That would be a huge expense. We're saving money by doing it here in-house at the plant.
The City and County of Broomfield's wastewater recovery facility employs approximately 20 employees. These wastewater professionals are responsible for treating approximately 2.3 billion gallons of wastewater annually. This wastewater comes from homes, schools, commercial and industrial facilities.
This is our screenings building, and basically all our influent wastewater comes in below where you're standing. From the collection system into here, basically gets taken all the large debris, the large screens out of the main flow of the channel. This is our Vulcan bar screen, and it's a stair screen, and basically it cleans the water that's coming into the plant, takes the large debris out of the water and compacts it, and then we can get hauled off to disposal. The water and material comes to this building, which is the grit removal system. Basically all your sand, your debris, your heavies get settled out of the water and then removed by our grit snail and our slurry cup here, dumped in a dumpster, removed for disposal. This is our secondary clarifier. Our mixed liquor comes in the center well, gets clarified through gravity, and then the effluent comes over the weir to our effluent channel that surrounds the outside ring of the clarifier. So this is our UV building. This is our UV setup. We've got 3 channels, main, the effluent from the clarifier comes down here, gets disinfected by UV light. Our UV system uses high intensity UV light to basically sterilizes the bacteria or any pathogens so it doesn't reproduce anymore, thus disinfecting the water. It's a safer and better system than the old chlorine gas system. So from our disinfection UV, basically we will peel off as much water as we need on a daily basis to run through this building, which is our reclaimed filter building. We take a portion of our water, discharge our effluent water from this plant and send it to the airport tanks. We have 2 reuse airport tanks. From there, in the wintertime, we actually discharge it into Great Western Reservoir. In the summertime, we actually use that for irrigation and go direct reuse to our parks, to the HOAs, to interlock into the golf courses, etc., for irrigation purposes. Feels pretty good. I mean, that's what we're designed to do.
The reuse water system allows Broomfield to use treated wastewater effluent a second time for irrigation purposes and has been the keystone of the city's water conservation efforts since 2004. The reuse or non-potable system is a diverse combination of water sources consisting of reclaimed wastewater effluent, raw water supplies from irrigation ditches, and direct stream diversions, all of which are combined and stored to supply water to approximately 940 acres of parks throughout the city and an additional 1,500 acres of non-city owned green spaces.
So here we're at the discharge point, or our effluent. Come through here to our measuring point. Water, the flow gets measured and discharged into Big Dry Creek immediately following this outfall. Well, for me personally, and I'll tell you personally, this is a little backstory on me. I actually helped build the water line from Carter Lake to the water plant at Broomfield here. Actually worked on the water plant back in '97 and then came here to the wastewater facility and built half of this plant, not by myself, but through construction. So personally, I've got a lot vested into Broomfield and the entire water system that we actually provide. And for me, it's a great place. There's no other place I'd rather work right now.
Although Broomfield is unable to physically recapture reuse water after it is used for irrigation, it is by no means at the end of its journey. All water that is not consumed by people, vegetation, industrial processes, or is lost to evaporation eventually makes its way back into our natural water systems, where it is used by downstream water users time and time again.
I've seen Broomfield change, I've seen it grow. I've seen this plant change, I've seen it grow. So we're gonna have to improve and get better day by day, every day.
But water is, especially in the West, the most precious resource that we have. The more people can conserve water and take care of it and be good stewards for it, the better off that the entire Western region is going to end up being. For me, I consider it the most valuable resource that we have.
It's important that we're all stewards of Broomfield's water resources. Water conservation and wise water use helps reduce the risk of future shortages, especially as we face long-term drought and the over-appropriation of water supplies throughout the Colorado River Basin. This means that each of us has a part to play in ensuring a dependable water supply for future generations in Broomfield and throughout the state of Colorado.